So I figured I'd just kind of show this off because I don't really see a lot of videos about this on the internet. Like a year ago I made this processor, but all I got done was the ALU of the processor. For those that don't know, that means Arithmetic Logic Unit. It handles all of the operations that the computer needs to do that involve, adding, subtracting, logical comparisons, all that jazz. And, I figured I'd just kind of go through that today. So, before we really go into this, I'm just going to kind of cover the inputs and outputs of the ALU before, we delve into that. So you'll see that there's 4 inputs for the operation because there are 16 possible operations that I had in mind for this computer. Yeah, you can put in any one you want. I don't remember which ones do what. It's been kind of a while since I dealt with this. So you got your first number input right here, where you can put in the first 8-bit value that you want to do a logical or mathematical operation on. And you got your second one right here, where you can, do the same thing with the first one, except it's the second one. Got your outputs. It's now 8-bit output because it's an 8-bit ALU, That's how that works. You got your clock. Nothing really special about this clock. I was going to do something with this micro instructions thing when I was planning out, fleshing out more of the actual processor, but that never happened. So if we go in here, how do I go in this thing? Oh, there is the button. Why does it only show up stop? Don't do this to me. Let me go inside the micro instructions. Please. Whatever. Okay, we're inside the micro instructions. So you see that the clock's just wired out to this 200 Hertz clock right here. It's really no big deal. I originally was going to make a clock with a 555 timer and some capacitors and that kind of stuff, but I figured for debugging I would just kind of, just use something I know is going to give me a correct value. Why is this zoomed out weirdly? Okay, yeah, so you got this 555 virtual. This isn't very important, but it's pretty cool. Yeah, this relay right here. It's all nice. Don't worry about it though. We're not here to talk about that today. We're here to talk about this thing. So we go into this, and you'll see it looks pretty complicated when you zoom out, but when you get in there, when you really get to the nooks and crannies of this thing, it's really not that big of a deal. So you'll see that there's this clock input right here. It goes over this bus. I don't really know why it does that, but it does. Wired up to this counter right here. Specifically, it's a 74 LS169. You can read. It's right there. It's a counter that counts up to 16 bits. I have it grounded, so it starts at 0 every time, and it loops back to 0. I don't even know what these things do. I never really know. It's okay, though. I wired these to 1 because I never load it, because I don't need to load it. It just counts. And down or up, we want it to go up, obviously, so I have it wired to 1, so it goes up. And the reason that I have this counter here is because for every instruction that's passed to this, it has 16 cycles to handle the instruction. That seems like a lot, and it really is a lot. I could have made this a lot better, but you'll see later that I needed to use these 16 cycles to do a really complicated operation. But yeah, you could do it in less. I decided not to because I didn't really have the time or patience to make something lesser than that. So this counts up, and it gives us the one of the cycles, or what it tells us what cycle that the. I need a script. Fucking Christ.